Hey guys, so I want to talk to you about why we're doing plan number 4 over here. So this lesson has to do with something called the Fermi paradox. And the reason we're doing this lesson relates back to our very first lesson on wicked problems, and it's going to integrate itself into everything else we've done this year. Before we get started, what is a paradox? So a paradox is something that has sound reasoning and a sound premise. However, it's going to lead to something that makes absolutely no sense, or it's impossible. By the way, a premise is the base of the argument, and the conclusion is the result of the premise. Let's take a look at an example. So here's a paradox from the book Catch-22. So the premise was only an insane man would go on military missions, and you can only get dismissed from the military if you're crazy. Let that sink in for 1 second. So you can only be dismissed if you're crazy. However, you have to ask to be dismissed. And only somebody who was not insane would ask to get out of the military. They have to be sane enough to be like, I gotta get out of here. So if you're sane, you wouldn't want to go on a military mission. But if you're sane, you also can't get dismissed because only crazy people get dismissed. Someone who's crazy would not ask, and they just go on the mission. So we have a paradox. Confused yet? Great, let's continue. So this lesson is going to talk to you about the Fermi paradox. So before I explain how mathematically unlikely it is for there to be no alien life, let me put this into perspective. All right, guys, so I'm going to pause that video, and now I want to slow down. I want to take a look at planet Earth. Now, we just compared California, which is right over here, compared to the entire planet Earth, compared to some other planets in terms of scale. Now, this scale is planet Earth, and this scale over here is comparing Earth in this diagram as a ratio of the Earth compared to everything else. So right now we only see planet Earth. And the reason that I'm pausing this to show it down is because this is completely incomprehensible for our brains to understand. So I'm going to try and break it down as much as possible so we truly understand how small we are. So we have California and we have Earth in this diagram. So over here, moving on to the second slide, this is the solar system. This little dot right here is planet Earth. And this little dot right here is the sun. Now, if we were to try and put a distance on this over here, the Earth is 93 million miles from the sun. So 93 million miles is the distance from right here to right here. That tiny little distance right there is 93 million miles. We cannot fathom that. I mean, it's not possible. But this entire diagram is at the same scale as the solar system. So in terms of our solar system, this entire area right here, the Earth makes up this little yellow dot compared to the sun, and we can see all of our other planets in relative distance to where we are. And even really, really, really big planets like Saturn, you cannot see in our entire solar system. And it only gets bigger. So take a look at not just our solar system, but the solar interstellar neighborhood. You guys see the solar system? Yeah, it's that little dot right there. You cannot even see it. I'll just put a dot on the screen just so you can see it. It's like right there. So that's our solar system compared to all of these other solar systems. That's a solar system, that's a solar system, that's a solar system. Like, these are all entire systems of suns with stars that are just like this one over here. So from that, it gets to our entire Milky Way galaxy, which is made up of solar systems. These things are all solar systems. You see this? Solar system, there's there's probably 100,000 solar systems in that circle right there. And of those solar systems, just one of those dots is our solar system. Like, this is really, really, really big. Then, if we go from our Milky Way, this is just one galaxy compared to all of the different local galaxies. Not even all of the galaxies, these are just the local galaxies. So our sun in our solar system is in this Milky Way galaxy, which we are one tiny dot of one of those things compared to everything else. And to make it even bigger, this is the supercluster. And the supercluster, if this is one local galactic group, that dot is this local galactic group. That tiny little thing is where everything we know that holds dear is close to us. Well, actually, technically it's over here, but yeah, point being, really, really, really small. And this is just the Virgo supercluster. There are other local superclusters where the Virgo supercluster is right over there. We know of another supercluster that's kind of close to us, not really close in terms of something we can comprehend, but there are so many superclusters. And this Virgo supercluster over here has our galactic group in it, that's that dot, which has our Milky Way galaxy, which has, I get what you are probably at this point right now thinking, how do I comprehend any of this? Well, this is in the same shape at a 1-to-1 scale as planet Earth, and this is our observable universe over here. And how to try and represent this observable universe is something that we're not going to be able to ever understand if that tiny little dot is this huge supercluster of different galaxies that we can see. But what you can understand is our observable universe is something that's kind of shaped something like this, where perhaps our entire universe is this cutout over here of this diagram. So maybe this diagram right here between those two yellow lines is going to be, if I shade this part in, this area is our observable universe, which contains the supercluster, which contains this one, this one, this one, all the way down to our planet Earth. Now that you guys understand just how big our universe is and how little Earth is, let's resume the video. It's time to investigate the Fermi paradox. Where is everyone, especially that space is so big?